substitution. Okay, now let's look at this example. Now we have the integral of x divided by x plus 2, and you can see we're told to assume that x is greater than negative 2. So we don't know how to take the integral of this right away, so we need to use U-substitution. So it may be difficult to know what to use for u. And it's always a little tricky to find u, or make the determination for the value of u. But you'll get better the more you practice, and there's certain patterns that repeat, and so you just start observing those patterns and you'll know what to plug in for u. But also you might make the wrong decision a few times, and that's fine. If you choose something for u and you try it, and it doesn't work, that's okay. Just go back to the beginning and pick something different for u, and try again. So if you make the wrong choice for u, that's perfectly fine. You just have to go back to the beginning and start fresh once you realize that your choice for u is not really going to work out. And the way you know that your u choice wouldn't work out is if your new integral you get after making the substitution isn't any simpler and you still don't know how to take the integral of it. So once we make this u substitution, we should get something that's fairly simple that we can easily integrate. That's the goal of u substitution. So in this case, let's try u equals x plus 2. So we need to find du dx. So then du dx would just equal 1. So then of course du is just equal to 1 times dx, which is just dx. So let's look at our integral. We know that x plus 2 is equal to u. So that part's taken care of. We know that dx is equal to du. So that part's taken care of. But we still have this x sitting here. Remember, when we use u substitution, all the x's need to be replaced with something in terms of u, and all the dx's need to be replaced with something in terms of du. So we need to take care of that x. It's still sitting there. So what we can do is we know that u equals x plus 2. So now let's just solve this for x. So we subtract 2 from both sides, and we get u minus 2 equals x. So that's what we can plug in for x up here, u minus 2. Okay, so now we've taken care of everything. We got everything in terms of u or du. So let's make our substitutions. So after making our substitutions, we now have this integral, u minus 2 divided by u. Now, it looks like we didn't really do that much. It's pretty similar to what we started with. But the benefit of what we did is now we have a monomial in the denominator. Over here we had a binomial. So we don't really know how to do x divided by x plus 2 at this point. But, unless we use partial fraction decomposition, which we could do that one. But you've only taken college algebra, and I don't think partial fraction decomposition is covered in college algebra. So instead we can do it this way. So now we have a monomial in the denominator after we did the u substitution. So we can split it up into u divided by u plus negative 2 divided by u. Remember, because it's a monomial, you can split it up like that. Now, of course, u divided by u is just 1, so we'll have 1 minus 2 over u. Now that we know that integration distributes over addition and subtraction, so we'll have the integral of 1 plus the integral of negative 2 over u. Now the integral of 1 is just u. The integral of 1 over u is ln of u. But we also have that 2 there, so the negative 2 there, so we get minus 2 ln of u for the integral of 2 over u. And then we just have plus our constant of integration, c. Now in this example, something's going to happen with the constant, so let me just call this c1 instead of c. So that's my constant c1. Okay, so I found the integral in terms of u. Now let's plug back in my value of x. So we know that u equals x plus 2. So this guy will be x plus 2, and we'll plug in x plus 2 here. So that gives me x plus 2 minus 2 ln of x plus 2 plus my constant c1. Now I can rewrite this so that I've collected the constant terms. You can see I have my arbitrary constant, which I don't really know what this one is. And then I have this constant. That constant I know the value of is 2, but it's still a constant. So now I have 2 plus C1. Whatever that value is, whatever I get from adding these two guys together, it's still going to be a constant. So let's name a new constant, which I'll just call C, and let that equal 2 plus C1. So like say C1 is equal to 5. So I have 2 plus 5, so I get 7. 7 is still a constant. So we don't know the value of C1, but we do know it's a constant. So we know that 2 plus it will still be constant. So I can just make those be one new constant term. So then my answer will simplify to x minus 2 ln of x plus 2 plus capital C, the constant. So that's my final answer for this problem. And whenever you have multiple constants added or subtracted together, or multiplied or something, you can just replace them with just one single constant. And so basically all the little constants just get absorbed together, and you can just write it as a single constant. And we just do that to simplify our answer a little bit. So instead of having like 5 constants being added together, we can just write it as one constant.